Hey everyone, I hope you're doing well. Welcome back to another video. Today I have 3 new interesting papers to share with you guys. If you guys are new to this series, essentially we are trying to introduce some new novel research papers to keep you guys updated with recent research trends and what people have been doing. So let's get started. The first paper I have for you guys is called Pangu Coder 2. So this paper essentially introduces a new code generation model called Pangu Coder 2 that achieves state-of-the-art performance on code generation benchmarks. But keep in mind that this is open source LLM code generation benchmarks. So if you compare to closed source models like GPT-4, it's not exactly state-of-the-art performance, right? But it outperforms all the other open source models. They also proposed a framework called RRTF, which stands for Rank Responses to Align Test and Teacher Feedback. RRTF it follows the principles of reinforcement learning, but they implement a ranking system. I won't go into detail about how this framework works. You can read more about it in the actual paper, which I have in the description below. And essentially, they're using RRTF to boost the performance of any pre-trained code generation models, right? So they can apply this framework to any of those pre-trained code generation models like StarCoder, CodeGX, right? So they did apply to StarCoder 15b, which is how they resulted in the model Pangu Coder 2. And this achieves 61.64% pass at 1 on human eval dataset and rendering it the state-of-the-art model for open source code generation models. So the human eval dataset is essentially a benchmark dataset for evaluating code generation models, consisting of 164 manually created programming problems. Okay, so they're essentially solving some programming problems. And so what do I mean by pass at 1, right? So pass at 1 on human eval evaluates whether the model can generate at least one valid solution for a given programming problem. And 61.64% means that this model achieves this for 61.64% of the 164 problems in human eval dataset. Okay? And through extensive evaluations on coder eval and lead code benchmarks, 2 other benchmarks, this model consistently outperforms all previous open source code LLMs. So it still underperforms GPT-4, as we can see here, but it outperforms the majority of the models. So that's still pretty impressive. Okay, so they also mentioned how they generated high quality training data. One of the core aspects of this paper is that they specified the importance of having high quality training data. So how did they obtain these high quality training data? So they applied this technique called Evo Instruct to create high quality data. Right? So for Pangu Coder 2, they started with 20,000 problems from Code Alpaca. The prompt is designed to take a problem and modify it by adding constraints, changing input and output format, modifying logic, etc. to create a more complex version of the problem. Right. So here are some of the evolution strategies they mentioned. So for example, add more test cases, right? The more test cases you have for a problem, the harder it is. So for example, if you have a problem with only one test case, it's very easy to brute force that problem. But if you have 3 test cases, for example, then it's much harder to pass the test case for that problem. And then increase the input size, basically making it more prone to time complexity errors, right? Okay. And they add constraints on code structure, modify input-output data types, and change solution approach requirements. So basically making the problems more complex. Okay, and the second paper I have to introduce today is called ARB, which stands for Advanced Reasoning Benchmark for Large Language Models. So what is this paper about? They introduced a new benchmark dataset, ARB, designed to evaluate expert reasoning abilities in mathematics, physics, chemistry, biology, and law. So why do we need this expert dataset, right? Well, large language models' understanding of many fields is reportedly shallow and unreliable. And expert reasoning in domains with specialized knowledge is essential for automated systems to replicate skilled professionals, right? So this is why this dataset is created. Well, benchmark really. And to make the benchmark more challenging than previous benchmarks, they extracted graduate level tasks from resources intended for domain professionals, right? So here is kind of the distribution for the number of questions and type of questions. So we see that the majority of the questions are in law, which makes sense because large language models are typically better at language, so they'll probably perform better on law anyways. And we have some numerical problems, which I think large language models would struggle unless they actually implement some prompt engineering techniques. So here are the results from the evaluations. And as we can see, they perform very poorly on numerical questions as expected. However, they perform relatively well on reading, science, and law. So conceptual, I assume. And since it's all languages, it's very easy for large language models to complete these tasks. So as we can see, closed source models like GPT-4 performs the best. Claude, this is Claude 1.3. I think before Claude 2 came out, this paper hasn't really mentioned. Yeah, so I think they tested this before Claude 2 came out. I think Claude 2 would perform relatively similar to GPT-4. Okay, so we can also see that GPT 3.5 Turbo is underperforming Claude 2. So, right, I think this is true in general. So if you can't afford GPT-4, I will highly recommend using Claude 2 over GPT 3.5 or ChatGPT, right? Okay, so we can see from the results that it performs poorly on numerical questions, but I don't believe the authors tried prompt engineering techniques like tree of thought or chain of thought. By applying those techniques, large language models can actually perform significantly better on math numerical problems. So, one of the things that you could try is apply prompt engineering to these large language models and see their performance on this benchmark. Okay, and the third paper I have to share with you guys today is called 3D Large Language Models, Injecting the 3D World into Large Language Models. So essentially, they just figured out a bunch of applications of large language models with 3D scenarios. So, we have 3D captioning, so it's able to describe the 3D scene here. We have 3D grounding, so it's able to localize and detect this leather chair, right? So it's able to do a bunch of 3D tasks here. And this has a lot of implications for future work in robotics, video games perhaps, 3D smart home, just smart homes in general, I think. So yeah, this paper is really cool. I won't go into detail about how they did this because the paper is relatively a simple read. There's pretty much no mathematics in that paper, so anyone can read it with a little background in deep learning. So I highly recommend giving this paper a read. Also, regarding prompt engineering, I would like to share with you guys this website. This website has really cool stuff on prompt engineering. I highly recommend giving this a look. It talks about all the prompt engineering techniques like chain of thought, tree of thoughts, right? This is super important stuff if you want to go into large language models. Okay, so this is a cool website I recommend. And this was the 3D LLM paper I was talking about, right? So as you can see, they have like zero mathematics in here. It's a relatively simple read. They have more stuff down there. But yeah, you can give this a read. It's not difficult. And this is the Pangu Coder 2 paper, right? Similar stuff. They go into much more detail about how the RRTF framework actually works. You can read more about it here. It does have slightly more math, but not too much. And finally, with this ARB paper. And this paper is a really simple read, so you can always read over this. Okay. So yeah, that's it for today's video. I'll be uploading more videos in the future. So if this is the type of content you're interested in, please subscribe and hit that notification bell. If you have any suggestions or comments, please leave them down in the comment section below and I will try to answer as soon as possible. All right. So thank you guys for watching and see you next time.